So yesterday we discussed the substitution rule, right? And also we discussed how to find the areas between the two curves. So we'll say if you're given two curves, some function f of x and another function g of x, then we can find the area enclosed by these two curves using the integration, right? What we need to integrate? We need to integrate the difference between the f and the g, right? So x changes from this a to this b. This is how the x changes. This is the y, okay? So the area enclosed by these two curves is equal to the integration of f of x minus g of x dx. So since I'm writing here dx means like x is changing. X changes from a to the b, right? X changes from a to the b. Okay, so it is really important for us to understand like the concept of the integration. So in the beginning we wrote down the integration is nothing else as a summation of the areas of the rectangles, right? So we wrote down, hey, the integration is the summation of the areas of the rectangles, where this f of xi gives you the height of the rectangle, right? And the delta x gives you the width of the rectangle. And if I take the limit when the n goes to infinity or when delta x goes to 0, then this becomes the integration of the function in this region. Okay? So while in the derivatives we didn't use the definition of the derivatives in order to find the derivatives, right? Because we have so many rules, we don't need the definition of the derivatives. The definition of the integration is very useful in most of the cases because integrating the functions is really difficult most of the times. Okay? So that is why it is really important for us to understand like what is the integration itself. Okay? And also in this course we are concentrated more on the applications of the integrations. Okay? In order to be able to apply the integrations to solve the many problems, we need to understand what does it mean. Okay? The integration means summing up the rectangles. Okay? So hopefully you understand that if I draw the function like this, for example, let's say this is my f of x is equal to the x squared curve. So if I say, hey, what is the area below this curve and the region from 0 to the 2, for example, the idea would be to divide this region to the many rectangles, right? Okay, so for example, let's divide this to this rectangle. So at this point, x is equal to 1, for example, I would like to make the rectangle, okay? What will be the area of this rectangle? The area of this rectangle is the width, which is, let's say, delta x, okay? And multiplied to the height. How do I know the height? How do I know the height of this rectangle? By evaluating the function, right? By evaluating the function here. Why? So, because of the idea of drawing the points in calculus, right? So hey, if I would like to draw the point with the coordinates 2 and 3, what I need to do? I need to go 2 units to the right. Yes? Then I need to go 3 units up. Right? 1, 2, 3. 3 units up. So this point will have the coordinates 2 and 3. Right? Its y coordinate tells me the height. Right? Do you see this? So this is the concept of drawing the point. So we need to go 2 units to the right and 3 units up. And the y coordinate is telling me the height of this point, right? So that is why if I would like to find the height of this rectangle, I need to find the y coordinate of this point, right? So since when x is equal to the 0, it should fulfill this equation. Okay, so y coordinate and x coordinate should fulfill this equation. F of x is equal to, or y is equal to the x squared, should be fulfilled for this point. Okay, so if you tell me the two numbers, so that if I put them to this equation, y is equal to the x squared, the left hand side should be equal to the right hand side. Okay, so in this case, what we say, so 1 and 1. So if I put this 1 and 1 to here, the right hand side is equal to the left hand side, right? So in this case, I can find the y coordinate and the x coordinate of the point here, right? And we've seen from here that the y coordinate of the point tells me the height, right? So that is why if I would like to find the height of the rectangle here, I need to evaluate the function's value at the point here, x is equal to the 1. Okay? So if I say a height, if I would like to make another rectangle at the x is equal to the 1.5, what will be the height of this function here? What is the height of this rectangle? So again, so I need to find the coordinates of this point, right? The coordinates of this point will be 1.5, right? And 1.5 in the square, which is 2.25, right? So 2.25. So the height of this rectangle is equal to 2.25. Do you understand why? Yes? Because the y coordinate of this point is 2.25. It tells us the height of this function at this point, right? It tells me the height of this function at this point. Okay? So how do I know that the y coordinate is 225? Because of this function, right? So this function usually looks like y is equal to the x squared, right? So we usually write y is equal to the x squared, right? What does it mean? So all the points on this curve, for all the points on this curve, if you put the coordinates of the points to this one, it should be equal, right? The left-hand side should be equal to the right-hand side. For every single point on this curve, if you put the x coordinate and y coordinate to this one, the left-hand side should be equal to the right-hand side part. Okay? So that is why it is equal to the 225. Okay? So that is why the height of this rectangle is 225. Do you understand this? Okay. So then yesterday we said, okay, so if I would like to find the area enclosed by the two curves, I need to again divide this to the many small rectangles, right? So here, I need to find the area of this rectangle. Let's discuss this. What does it mean conceptually? So conceptually, the width of this rectangle is delta x, right? And what is the height of this rectangle? Is the height of the red curve minus the height of the blue curve, right? So the height of the red curve minus the height of the blue curve gives you this one, right? So basically, f, so let's calculate this at some point x0, okay? F of x0 is this height, right? And g of x0 is this height, the red one, okay? If I would like to find the height in between, I need to subtract them, right? So this height in between is f of x0 minus g of x0, right? So for every single rectangle, the area will be f of x minus g of x multiplied to the delta x, right? And since I can take its limit, so if I would like to find the area exactly, I need to get a lot of rectangles, right? So when n goes to the infinity, okay? N is the number of the rectangles. Then it becomes the integration, okay? So it is really important to understand the concept because today we're going to discuss how to find the volumes using the integration, okay? So that is why you need to really understand what does it mean. So let's do a couple of examples, more examples. So we're given two curves, f of x is equal to the sine of x, and g of x is given as cosine of x. So we need to find the area bounded by these two curves in the region when x changes from 0 to pi over 4, pi over 2, sorry. So first of all, let me draw the functions. So do you remember how the curve of the sine looks like? in the region between 0 and pi over 2. So what is the sign of 0? Is 0, right? What is the sign of pi over 2? Is 1, right? So at the pi over 2, the sign gives you 1, right? So it should look like this, roughly, right? Okay, what is the curve of the cosine? So this is, the cosine of 0 is 1, right? And the cosine of pi over 2 is 0, right? So it will be like this, right? Okay, so we need to evaluate this region. These two regions. Okay, is it clear? So the red one is the sine, and the blue one is the cosine. So hey, if I tell you, tell me what is this region in below, what you will need to do. So we know that the integration gives us we can use the integration in order to find the areas below some curves, right? Also, so the area here will be equal to the integration of this red function until the pi over 4, right? From 0 until the pi over 4. And integration of the blue curve from pi over 4 until pi over 2. Do you understand this? Yes? So because of the definition of the integration, right? So if I say, hey, tell me what is this area? This area, the green one, will be integration of the red one of the sine from 0 until pi over 4, and integration of the cosine from pi over 4 until pi over 2. Do you understand this? Yes? So I'm asking you a different question. So I'm asking you, what is the integration, what is the area of this, dashed with the blue color? What are the areas? So you can find this area separately and this area separately, right? So we know that conceptually the area between the curves is equal to the integration of the difference of the functions, right? Since this function is above than this one in the first region, and vice versa in the second region, we need to integrate them separately, okay? Integration of the first region and integration of the second region separately. So the area, let me denote this as A1, and let me denote this as A2, okay? So A1 is the integration of, what is the above function? Cosine, right? Of the cosine of x from where to minus sine of x, right? Minus sine of x. Do you understand why I'm subtracting this? Right? Because I would like to find the width of the rectangle at every single point, right? The height of the rectangle at every single point, right? For example, if you choose so here I will put the dx, right? dx means whenever you choose the x from 0 until the pi over 4, so from 0 until pi over 4, the width, the height of the rectangle will be equal to the cosine of x minus sine of x, okay? So this x is changing. This is the variable, okay? You will choose any x between 0 and pi over 4, okay? Whenever you choose this, the height of the rectangle will be cosine of x minus sine of x, okay? This is what does it mean. Do you understand this? Okay. So this will be equal to, so the rest is simple technique, right? Or not simple, or technical question. So the antiderivative of the cosine is sine of x. Antiderivative of the minus sign is minus plus cosine of x. So we need to validate this from 0 until pi over 4. If you put the pi over 4, you will get square root of 2, right? 2 multiplied to the square root of 2 over 2, right? Because sine of pi over 2 and the cosine of pi over 2 are equal to the square root of 2 over 2. Minus sine of 0 is equal to the 0, cosine of 0 is equal to the 1, minus 1. Okay, so this was square root of 2 minus 1, right? So this is the area A1. So what is the area A2? Is equal to the integration. What is now above? Sine is above. We need to subtract the cosine from this. And we need to integrate this from pi over 4 until pi over 2 dx. So do you understand what does it mean? Like when you put this borders, like This is not just like, so the meaning of this numbers on the border is like the x changes like this, okay? So you're like making partitions rectangles like this, horizontal, vertical rectangles, where the width will be delta x, okay? And you're changing the x from pi over 4 until pi over 2. The rest is technique. So the antiderivative of the sine is minus cosine of x. Antiderivative of the cosine is minus sine of x. We need to put this from pi over 4 to the pi over 2, right? If you put the pi over 2, what you get? Minus 1, right? Because cosine of pi over 2 will be 0. Sine of pi over 2 will be minus 1, right? Now, minus, we need to put the minus cosine of pi over 4. What is the, so this is square root of 2 over 2, right? Minus square root of 2 over 2, which is what? Which is the same as square root of 2 minus 1, right? So the area dashed with the blue color is equal to the 2 multiplied to the square root of 2 minus 1, okay? So A1 plus A2. A1 plus A2 is equal to 2 multiplied to the square root of 2 minus 2. Good? So let's do another example. So conceptually, so in order to solve the next example, you need more understanding of the integration example. So let's say we're given the t curves, y of f of x is equal to x minus 1, and g of, the second curve is like this. Y squared is equal to the tx plus 6. Okay. So f of x is equal to the x minus 1. And the second one is y squared is equal to the tx plus 6. So what do you think? What is the form of this one? What is the form of this one? This is the parabola, right? But this is not the usual vertical parabola. It doesn't look up or it doesn't look down. It looks to the right. Yes? It looks right. Okay? So when you have y squared is equal to some linear function of the x, it will be parabola which is light on the x line. Okay? Whether it looks like right, or it looks to the right, or it looks to the left. Okay? In this case, it looks to the right. Okay? So let us try to do this. So what will be the most right point here? The most right point. Minus what? Okay, so if it is difficult for you, what you can do is you can just change with the places of the x and y. Okay, so change the places. So write down x squared is equal to the ty plus 6. Okay, so if you find a y from here, it will be equal to x squared over 2 minus 3. Right? This looks like a usual parabola, right? Now, but the thing is, like, this is now y, okay? Do you understand this? Because you changed the x with the y, right? Do you understand this? This is now y. So if you draw this, first of all, what you need to do is you need to know what is the minimum point or what is the maximum point, right? In order to do this, you can just take the derivative, equalize this to the 0, and tell me the point. Minus 3, right? If you take the derivative and equalize this to 0, it gives you a minus 3. Okay, so here at the minus 3, this is the most right point. Okay, so it will be parabola. So when the y is equal to the 0, what is the x? When the x is equal to the 0, what is the y? Plus minus square root of 6, right? So this will be plus minus square root of 6. So here and here, so we need to draw this. like this. So this is the curve. Y squared is equal to the 2x plus 6, okay? The ordinary parabola, which is light, is the x line, okay? Now, the second curve is simple line, right? Do you remember last time we discussed that if I would like to draw the line, we need to find the 2 points, right? So could you please tell me any 2 points which is on this line, which are on this line? So first point, so when x is equal to the 1, y is equal to the 0. When x is equal to the 1, y is 0. Okay, for example here, what is the second point? When x is equal to the 0, y is equal to the minus 1, right? Okay, so this is minus 1 here, this is 1. Do you understand how we draw this? Yes? So if you're given the curve, y is equal to the x minus 1, in order to draw this, you need to know the 2 points which satisfy this equation. Okay? The first point is, just take the x to be equal to the 0, right? And put this to the equation, it gives you y. Y will be equal to the minus 1, right? So this point is on your line, right? Why? Because if you put the x and y coordinates of this point to the equation, the left-hand side will be equal to the right-hand side, right? So how to find the second point? Just equalize the y to be equal to the 0 and find the x. Okay? So this will be 1, right? Now if you put the coordinates of this point to the equation, the left-hand side will be equal to the right-hand side, right? So if you put the 2 points and connect them, you will get the graph of the line. Okay? Now what we need to do is we need to find the area between these 2 curves. Okay? So the thing is, we cannot do this as usual, as in our previous examples. Okay? Because the thing is, if I would like to make the rectangle here, I don't know what to subtract from what. You know what I mean? So previously we say that, hey, if I would like to find the area, conceptually I need to make the rectangle, right? For example, like this. So this kind of rectangle, right? So the width of this rectangle will be delta x, and the height would be the red curve, the black one, minus the green one, right? The height, h, right? Now the problem is, like, if I would like to make this, like a lot of rectangles in this region, I need to be able to make the rectangles here as well, which I cannot do, right? Do you understand? So I cannot subtract this from this somehow. Or either you need to make the 2 curves, right? 2 functions. This will be above will be one function, below will be different function. Okay? So there are 2 ways of solving this problem. Either would do this like this, like I either would do a lot of work, so the work will be like this. So we will split this area into the 2 or into the 3. So the first region will be from here until the end. Okay, this is the first region. Okay, the second region will be this one, and the third one will be this one. Okay, we can find every single region. We have to find every single region separately. Then at the end we need to sum them. Okay, so what will be this region? The dash was the blue. The region dash was the blue will be equal to, so let me call this as A1. A1 region is equal to the integration of the square root of 2x plus 6, right, minus x minus 1 dx, so x changes from some value to some value, okay? So A2 will be the integration of the square root of 2x plus 6 dx, okay? And A3 will be integration of minus 2x plus 6 dx. Yes? I mean, you have to divide it here, exactly here. You cannot do this below or above. It doesn't work. You have to do this here. Okay? So I need to know this point, the coordinates of this point. How to find the coordinates of this point? Or this point? The intersection points. So how do I know the coordinates of the intersection points? By solving the system, right? So we need to solve the system. Y squared is equal to the tx plus 6, and y is equal to the x minus 1, right? Why I have to solve the system in order to find the intersection points? Adam? So why I need to solve this system in order to find this intersection points? So what does it mean, the system? System of equations. No. So why we have to make the system? Why we cannot just solve them separately? The solution of every equation in the system should be common to all equations. Yes? So the solution, one solution, should satisfy all the equations. Okay? Or two solutions. Or all the solutions of the system should be satisfied for all the equations. Okay? Now, do you look here? So in the intersection points, we've got 2 points, right? Which are satisfied by both of the equations, right? If you put the coordinate of this point to the black one and to the green one, they will be satisfied, right? Or if you put the coordinates of this point to the black one and to the green one, they will be satisfied, right? Both of the equations will be satisfied, right? There are no other points so that the equation of both equations will be satisfied, right? For example, if you choose this point, right? So minus 3 and 0. This equation will be satisfied, the first one. The second one will not be satisfied, right? So if you put the minus 3 instead of x, minus 1 is not equal to the 0, right? Do you understand this? For example, this point, minus 3 and 0, is not satisfied by the second equation, right? While the intersection points, if we find them, they satisfy both of the equations at the same time, okay? Do you understand this? So that is why we have to solve the system. So the system is called like a couple of equations where they have a common solution. Okay? So in order to solve this, so let me just substitute the y from the second equation to the first one. So this will be x squared minus tx plus 1 is equal to the tx plus 6, right? So if I put everything to the left-hand side, it will be x squared minus 4x minus 5, right? I can regroup this as x minus 5 and x plus 1 is equal to the 0. Can I do this? Okay, so x minus 5 and x plus 1, right? The coordinates of this point here, x coordinate will be minus 1, right? The coordinate of this point here, the x coordinate will be 5. Okay? How to find the y coordinates? So x1 was equal to the minus 1, x2 is equal to the 5. In order to find the y coordinates, we need to put this to any of the equations. Okay? So this will be satisfied by this equation and by this equation as well. Both of them will give you one y, the same y. Okay? So let's put this to the second equation. If you put the minus 1 to the second equation, what does it give to you? Minus 2, right? Minus 2, sorry. The coordinates of this first intersection point is minus 1 and minus 2. The coordinates of the second point is, what are the coordinates of the second point? 5 and 4, right? How did I find this 4? By substituting the 5 to the second equation, right? Okay. Now, could you please tell me the bounds of these 3 integrations? So from how the x changes. So do you understand this? So this blue area, A1, is the integration of the difference of the black one from black one and the green one. And x changes from which value to which value x changes? X changes from here, from -1 until 5. Right? X changes from -1 until 5. Okay? So, in the second area, A2, how the X changes? From -3 until -1. Right? From -3 until -1. And the last one? The same, right? From -3 until -1. Okay? By finding the 3 areas and by summing their absolute values, we can find the area enclosed by the C curves. Okay? Which was not so easy, right? So we need to do a lot of work. Is it possible to solve this problem differently? Using the integration. Differently, but using integration. I mean, we're still summing in this problem as well. We're doing the summation. The same method, the same integration, slightly different. Okay, let me draw this again. So in a -3, so square root of 6 minus square root of 6 should be parabola which lied on the x curve. And the second one is, I need to connect these 2 points, right? -1 and +1. I need to connect them. It should be like this. This area. Okay? So could you, do you have any ideas how to do this? Again, making the rectangles, okay, and summing the areas, we can find the total area. Yes? No. Again, rectangles.
All the upper side and the lower side. Positive and negative.
We have to do the horizontal rectangles. We need to do the horizontal rectangles. So let me do the horizontal rectangle here. Like this one. Okay? What is the area of this horizontal rectangle? This is the width, right? What is the width here? For example, let's say you choose some point y0 now, right? Not x0 anymore, y0, right? So you need to find the value of the function here, right, on the black curve, right? Then you need to find the value of the function here on the red curve. Then you need to subtract them in order to find the width of this rectangle. Do you understand this? Yes, so here, it should be like this. So you need to find it here, the coordinates of this point here and coordinates of this point here. Could you please tell me what are the coordinates? If this line, horizontal line, is at the y0, at some point y0, could you please tell me the coordinates of this point and this point? So the first curve, the black one, is y is equal to the x minus 1, right? If you find the x from here, what you get? Y plus 1, right? So what is the coordinates of this point here? Is y0 plus 1 and x. And y0. Yes? The coordinates of this point is equal to the y0 plus 1 and y0, right? Do you understand this? So for both of these points, the y coordinate are the same, right? The height from the x are the same for both of these points, right? The only difference is on the x coordinate, right? Do you understand this? So in order to find the x coordinate, you need to find the x from this equation and just substitute the y to here, okay? It tells you the x coordinate of this point. What is the coordinate of the second point? So the function was equal to the y squared is equal to the 2x plus 6, right? We have to first of all find the x from here, right? So if you find the x, what you get? Y squared minus 6 divided to the 2, right? The coordinates of this point here is equal to y0 in the square, minus 6 divided to the 2. This is the x coordinate. And the y coordinate will be simply y0. Okay? Yes? Or you can say, okay, so this will be, this function x will be, let me call this as f of y. Okay? And let me call this as g of y. Okay? So if you put the y0 if you give the y0 to one of the functions, it gives you the x coordinate, right? So we need to find the x coordinate of these 2 points, and we need to subtract them in order to find the width of the rectangle, right? So the width of this rectangle is f of y0 minus g of y0, right? So we need to multiply this to the delta y, right? dy. And we need to do summation from which value of the y to which value? So from here until here, right? So what is this here? Do you remember the coordinates? It was minus 2 here, and it was 4 here, right? From minus 2 until the 4. Okay, do you understand this? So I need to make a lot of rectangles, like this rectangle, or this rectangle, or this rectangle, and so on. For all of the rectangles, the width will be f of y minus g of y, and the height will be delta y. Okay? For all of the rectangles. Then we need to integrate f of y minus g of y with respect to the y now. Okay? So instead of making 3 areas, we can make only 1 area. Okay? By integrating functions with respect to the y. Okay? We are using the same concept. It is important to understand the concept, okay, of the integration. So let's do this. So this will be integration from minus 2 until the 4. So f of y is equal to the y plus 1 minus g of y is equal to the y squared over 2 minus 3, right? We need to integrate this from minus 2 until 4, okay? So let me simplify everything. So let me write this as from minus 2 to the 4. So y plus 1 minus y squared over 2 plus 3, right? We integrate this with respect to the y. So this is equal to the integration from minus 2, or let me integrate. So the integration, the antiderivative of the y is y squared over 2, right? Antiderivative of the 1 is y. Antiderivative of the y squared over 2 is 1 over 2 multiplied to the y cubed over 3, right? And the antiderivative of the 3 is 3y. Okay? So you need to put the values 4 and minus 2 and evaluate them. And if you do this, at the end, you need to get 18. Okay? So the second one is easier, actually. Good? So it depends on the area. You need to choose whether to integrate with respect to the x or whether to integrate with respect to the y. Okay? It doesn't matter. You integrate this. You make the horizontal rectangles or vertical rectangles. Okay? The concept is important. So let's do one more example. This one, so example. So let's say we're given the curve. Y is equal to the x squared, and y is equal to the 4x minus x squared. So we need to find the area between these two curves. Okay? Is it possible to find the area enclosed by these two curves without drawing them? Yes, right? Unless we understand what we're doing, unless more or less we know what is this, right? So I know that this is parabola, right? And this is also parabola. Any quadratic function is a parabola, right? Do you understand what does it mean, quadratic function? Y is equal to the ax squared plus bx plus c is some parabola, right? The only thing which I need to know whether it looks up or it looks down, and what is the minimum and maximum points, right? So how do I know whether the first parabola looks down or up? So just take the two derivatives, right? Twice the derivative is 2, simply, right? It means that it looks up, right? Upwards. And this one is, the second derivative is minus 2, so that is why it looks downward, right? So the area should be between them, right? And obviously, if the one is looking up and the second is looking down, they intersect in the 2 points, right? I need to find the intersection points, okay? So let's try to do this without doing this, and we'll try to see whether this is true or not, okay? So first of all, we need to find the intersection points. So in order to do this, we need to solve the system. So do you understand why we need to solve the system, right? So intersection points are the special points. They satisfy both of the equations at the same time, right? So that is why we need to solve the system. So making the system is again means tell me the solutions, tell me the x and y, the values of the x and y, which would be satisfied for all the equations, okay? Yes? So in order to do this, we can merge two equations, and we can write x squared is equal to the 4x minus x squared. So if you put everything to the left, it will be 2x squared minus 4x is equal to the 0. Okay? Then I need to take out 2x from the brackets, and what is left is x minus 2. Right? Equalizes to the 0. Okay? So intersection points, the x coordinates of the intersection points are x1 is equal to the 0, x2 is equal to the 2. How to find the y coordinates of the intersection points? By substituting the x values to the y, right? If you put x1 to the first equation, what you get? 0 for both of them, right? So if you put the x to the first one or to the second one, you will get the 0, right? If you put now 2 to the first one, what you get? 4. If you put this to the second, it will be 4 multiplied to the 2, which is 8, minus 4, which is again 4, right? So y2 is equal to the 4. y2 is equal to the 4. Okay? Now, we need to integrate. So what do you think? Which is the above function? The first one, which is looking up, or the second one, which is looking down? Second one is higher, right? So we need to subtract x squared from 4x minus x squared, right? This is the upper, right, because it looks down, minus x squared, because it looks up, right? And with respect to the x, and how the x changes? Between the two intersection points, right? From 0 to the 2. From 0 to the 2. So this is equal to the integration of 4x minus 2x squared. Yes? dx. I'm making the vertical rectangles. Yes, vertical. You cannot make the horizontal. If you make the horizontal rectangles, you need to split the area again into the 2. No. So that was like a different example. This is different. Okay? So from 0 until the 2, we need to integrate 4x minus x squared because it looks down, minus x squared because it looks up with respect to the x. And this is equal to the, what is the antiderivative of the 4x? Is 2x squared, right? Because if you take the derivative of the 2x squared, it gives you 4x, right? And what is the antiderivative of the minus 2x squared? Is minus 2x cubed over 3, right? So we need to put the values from 0 to the 2. If you put the 2, you will get 2 multiplied to the 4, which is 8, minus 2 multiplied to the 8 divided to the 3, right? So this is equal to, so 2 multiplied to the 12, which is 24, minus 16 divided to the 3, which is 8 over 3. So the area between these two parabolas is equal to the 8 over 3. So in order to illustrate here what we found, we can draw them. We can try to draw them, right? So they are like this. The first one is simply y is equal to the x squared parabola, right? And the second one is y is equal to the 4x minus x squared parabola. So this is at the point 2. It will be like this, roughly. Okay? We found out this area. Do you understand this? We found out this area by making, again, the vertical rectangles, right? For each of the vertical rectangle, the height will be the blue curve minus the red curve. Okay? Then we have to make the rectangles, such rectangles, for all possible axes from 0 to the 2. Good?